So let's welcome in next lecture of MAT-201, that is the integral calculus. So in previous lecture we have seen the reduction formula to find the integration of cos raised to nx dx, and we have seen it for the case if n is an even integer. If n is an odd integer, then we have seen different method to find that integration. So here we will see the formula for integration of cos raised to nx dx between 0 to pi by 2. So here we can write formula, and it is formula for integration of cos raised to nx dx, and it is integration from 0 to pi by 2. So already we have seen the same formula for integration of sin raised to nx dx between 0 to pi by 2. So here, so this integration is nothing but, see, so it is equal to n minus 1 divided by n into, so it is n minus 3 divided by n minus 2 into, it is n minus 5 divided by n minus 4 into up to. So it will be, so 2 upon 3, and it is case if n is an odd integer. So if n is odd or odd integer, you can write, and the value of this integration is n minus 1 divided by n into, that is n minus 3 divided by n minus 2 into, so n minus 5 divided by n minus 4 you can write into up to, that is half into pi by 2. So it is case when n is an even integer. So if n is an even integer, then value of this integration is equal to this. Same formula we have seen for integration of sin raised to nx dx. So what is the derivation of this formula? So first I will make bracket for this. Yeah. Yes. So first we'll derive this formula, or what is derivation of this formula? It is simple and which is similar. So to integration of sin raised to nx dx between from 0 to pi by 2. So derivation of this, or you can write proof of this formula. So let us consider integration of, yeah. So let's suppose in. So we are taking in as, it is integration from 0 to pi by 2 of cos raised to nx dx. So again here also we'll use the integration by part, and for that we can write, so already we have seen in previous previous section, that is integration of 0 to pi by 2. So it is cos raised to n minus 1 x into cos x dx. So here we are writing, let us see, so just write n as n minus 1 plus 1. So you can write this power n as, see, n equal to n minus 1 plus 1. So we split it and we write it as integration from 0 to pi by 2 of cos raised to n minus 1 x into cos x dx. So here we are using integration by part. So we'll consider this function as first function and this function as second function, and in integration by part. So what will be this? So using integration by part, so you can write the value of this integration will be, see, so it will be, so minus of sin x, so integration of cos x, that is sin x, and cos raised to n minus 1 x will be as it is. So cos raised to n minus 1 x, and it is divided by n, and limits are from 0 to pi by 2. So you can write it plus, or you'll write, already we have seen this reduction formula, So directly you can write that is n minus 1 divided by n, and it will be integration from 0 to pi by 2. It will be cos raised to n minus 2 x dx. So what will be this? What will be first term? Let us see. So if you put here first, suppose x equal to pi by 2, then what happens? So cos pi by 2, that is 0, so this term will be 0. And if you put x equal to 0, that is lower limit, so first term will be 0. See, and in result of this, so this first term, total this term will be 0. So value of this term will be 0. So what will be this? It will be, see, so we'll write in as that is 0 plus n minus 1 divided by n integration from 0 to pi by 2 of cos raised to n minus 2 x dx. That is, so what will be this? So what is value of this? Already we have seen what is in? In, that is integration from 0 to pi by 2 cos raised to nx dx. So if I replace this n by n minus 1 or n minus 2, so it will be in minus 1 or in minus 2. So here, so what will be in? So you'll write, see, in as n minus 1 divided by n, and it will be in minus 2. So it is in minus 2. You can write this as suppose equation number 1. See, so here, if you put, suppose n equal to n minus 2. So let us put n equal to n minus 2. So you will get, so repeated application of this equation 1 gives that. So repeated application of an equation 1 gives that. So what will be in minus 2? So if I replace n by n minus 2 in equation number 1, so I will get, so in minus 2, it will be equal to, so here I'm putting n equal to n minus 2, so it will be n minus 3 divided by, it will be n minus 2, and it will be in minus 4. So you can continue this process. So what will be next term? So in similar way, if I replace, suppose here n by n minus 2 again, or here you can replace, that is in equation number 1, you can replace n by n minus 4, or in equation number, so let us call this equation as equation number 2. So in equation number 2, if we replace n by n minus 2, so I will get, let us see, so it will be in minus 4, and it will be, so n minus 5 divided by n minus 4, and it will be in minus 6. So again you can call this equation as suppose equation number 3, and you can repeat this process. So continuing in this way, so what we will get? So we'll get, so if I replace, so here n by, so I'm putting suppose n equal to 6, then what happens? Or yeah, so if I replace n by 6, I will get I2 equal to, or if I replace n by 7, so what I will get? So it will give us I3 equal to, so I'm replacing n by 7, so it will be 7 minus 5, so that will be 2 divided by 3, and it will be I1. Is it okay? So here I'm putting n equal to 7 means resulting integer is an odd integer. See, so if n is an odd integer, and see, if I put n equal to suppose 6, means I'm putting even integer, I'm putting value of n as an even integer, so in that case I will get, so it will be I6 minus 4, so that is I2, and it will be, so 6 minus 1, that is 1, so it will be half, and that is I0. So it is in the case if n is an even integer, if n is an even integer. See, but what is I1 and what is I0? But what we have? But we have in, that is integration from 0 to pi by 2 of cos raised to nx dx. So let us put here, suppose n equal to 1. So what happens? So if we put n equal to 1, so we'll get the value of I1. So therefore, what is I1? That is integration from 0 to pi by 2 of cos raised to 1x, that is cos x dx, and that will be sin x, and limits are from 0 to pi by 2, and which is nothing but 1. So it will be 1 minus 0, and that is equal to 1. And similar way, see, and what is I0? So if you put, suppose n equal to 0 here, so we'll get I0, that is integration from 0 to pi by 2 cos raised to 0x, and it is just dx. It will be, so limits of x from 0 to pi by 2, and you will get, so that is pi by 2 minus 0, and it is nothing but just pi by 2. See, so what is value of I0? So value of I0 is pi by 2, and the value of I1 is equal to 1. So you can resubstitute these values here, and we'll get, so after back substituting these values, so what we'll get? So back substituting the values of I0, I1, then I2, I3, it goes to up to suppose In minus 1, and then we will put the value of In minus 1 in In, or In minus 2 in In. So that will depend on whether your integer is even integer or odd integer. Yeah. So we write In minus 2 in terms of In minus 4. We write In as In minus 2. So it will be In minus 2 and then In. So let us see. So what we'll get? So we'll get, see, In equal to, that is integration from 0 to pi by 2 of cos raised to nx dx, and it will be, so again there will be two cases. If n is an odd integer, so you'll get different value, and for even integer you'll get a different value. So it will be n minus 1 divided by n into n minus 2 divided by n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4 into up to, that is, to form 3, if n is an odd integer. If n is an odd integer, and so you'll get n minus 1 divided by n into n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4 into up to, that is, half into pi by 2. So it is for even integer. So if n is an even integer, so this is the required formula for the integration of cos raised to nx dx from 0 to pi by 2. So this is the finite integration, and value of this integration is given by this formula. So we'll see some examples on this formula. So first example, so evaluate the value of integral. So question is that evaluate the integral, it is from 0 to pi by 2 of cos raised to, suppose, 9x dx. So solution, very simple. So here, see, what is n equal to 9. So using the previous formula, or so we can write, or we have, so integration of cos raised to 9x from 0 to pi by 2. So it will be, let us see, actually do that. So here n is an even odd integer. So in as a note you can write, so here n equal to 9 is an odd integer. So you have to use this formula in the case of odd integer. See, so it will be 9 minus. So what is this formula? So n minus 1 divided by n. So it is 9 minus 1 divided by, it will be 9 into, so it will be 9 minus 3 divided by, that is 9 minus 2. So then it will be 9 minus 5 divided by 9 minus 4. Then it will be 9 minus 5. Then it will be 7 divided by, that is 9 minus 6. And then 9 minus 9. So that term is not there. So what are the values of this? Yeah, this. So it will be 8 divided by 9 into, so it will be 6 divided by 7. Then it will be, yeah, 4 divided by 5, and that will be 2 divided by 3. So what is the value of this? So you can calculate this value, and it will be 64 divided by 945. So this value of this integration, that is integration from 0 to pi by 2 of cos raised to 9x dx. So in similar way you can find, so you can solve second example. So second example is that evaluate the integral. So it is given by, so 0 to pi by 4 cos raised to, suppose 6 to tx. Sorry. So it is 2t dt. So integration from 0 to pi by 4 of cos raised to 6 to t dt. So here you have to make some substitution for that. So here, see, so what you have given solution. So here, see, first put, so 2t is equal to x. So what it imply? So it will imply 2t 2 dt equal to dx. And for that, so limits will be also changed. So if x equal to 0, see, if x equal to 0, what is value of, yeah, sorry, if t equal to 0, what is value of x? Then x will be again 0. And if t is equal to, suppose, pi by 4, then what is x? So in that case, x will be pi by 2. So therefore, what will be resulting integration? So resulting integration can be written as, can be written as, see, so it will be integration from 0 to pi by 4 of cos raised to 6 to t dt, and it will be, so here we are replacing t by x, means we are putting 2t equal to x. So we are changing the variable of integration by x. So it will be integration from 0 to pi by 2. So cos raised to 6x, and what is value of dt? So it is, yeah, so dt will be dx upon 2. See, so that is half you can take outside of integration, that will be dx. So what is the value of this integration? That is half, and we have this formula. So using this formula, so this integration will be, that is 6 minus 1 divided by 6 into 6 minus 3 divided by, that is 6 minus 2 into 6 minus 5 divided by, that is, see here n is an even integer, so be careful. So it will be 6 minus 5 divided by 6 minus 4, and that is pi by 2. So since you can write here, since, yeah, so here n equal to 6 is an even integer. So what will be resulting value? So it will be, So half into it will be 5 by 6 into it will be 3 by 4 into half into pi by 2. So resulting value will be, that is 5. So yeah, you can simplify it. It will be 5 by 64. So this will be the resulting value of this integration. That is integration of cos raised to 6 to tdt from 0 to pi by 4. So in similar way, you can solve some examples as homework. So this homework will end the chapter, that is chapter number 3. So I will give some examples as homework. So question is that evaluate the following integrals. First, yeah. So it is integration from 0 to a of x raised to 4 divided by, so it is square root of a square minus x square dx. So I will give some hints for this example. So second example, that is integration from 0 to 1 of x raised to 7 divided by, that is square root of 1 minus x square dx. Then third example, integration from 0 to 1, that is x square into 1 minus x square its power 3 by 2 dx. And fourth example, you can solve, that is integration from 0 to 1 of x raised to 6, sorry, so you can take x square, yeah, x square 2 minus x square and whole divided by the square root of 1 minus x square dx. So I will give some hints for solution of these problems. So in first example, that is, yeah, integration of x raised to 4 divided by square minus x square. So here you can put, so these are the hints. Put here x equal to a sin theta. So ultimately you can transfer this integration in our required integration. So in second problem, so you can put c. So you can put x equal to sin theta. And in third example, you can put, so hint is that you can put, yeah, x equal to again sin theta. In fourth example, you can put, so again x equal to sin theta, and solve these problems. So this will be end of the chapter. So next lecture we'll start next chapter, that is chapter number 4, the definite integral as the limit of sum. So next chapter, chapter number 4, definite integral as the limit of sum. So we'll stop here.